Welcome to Ocean Science. Today I will tell you how these shadow pools are formed. These strange formations can be observed in a normal pool or also in a natural pool in the ocean. These shadows can be formed in specific conditions, and I say shadows because they are not really shadows. A shadow is when something is between the ray of a light and the background, so this object blocks the path of the light and we can see the silhouette. But in this case we don't have this situation, so it's not really a shadow. In this case we have the splitting of a light ray. So the light can pass through, but his trajectory will be modified by the changing on the medium. This is a similar effect that we can see in the mirror that are concave and convex, where the light changes its direction. In this case we change from the air to the water, and part of the light is reflected and part of the light is refracted. This is called the Snell's law, discovered in the 1621 by the astronomer and mathematician Wilbur Snell, also called Snellius. This is based on the Hughes principle and a statement that says that all the points that we have in a wavefront can be a new source of a new wave, depending on the velocity of these waves. This was proposed by the Dutch astronomer and mathematician Christian Huygens in the 1690. Okay, but in this effect, always some light passes through. So how can it be possible to see these shadows? We see how in a plane we have an angle of refraction and reflection. But if we incline this plane, we have a bigger angle. And if we do the same with the other part of the surface of water, we will have two angles that put the light outside of the center. This situation is the situation that we have in a vortex. But we don't see always these shadows, so this vortex. As I said before, this is a formation that we will have in a specific conditions. The fluids can be divided on laminar and turbulent, and they will be depending on the Reynolds number. This concept was introduced by George Stokes in the 1851, but the name of Reynolds number was put by Arnold Sommerfeld after Oswald Reynolds used this number and popularized its use. This number will be depend on the density, the velocity, and the viscosity of the fluid, and also the area that this fluid will pass in a channel. If this number is smaller than 3000, we will have a laminar flow, but if it's bigger than 3000, we will have a turbulent flow. A vortex is a stable structure of the turbulent flows. This can be explained by a channel. We will have two walls and fluid that goes through. We will have the maximum velocity on the center and the minimum velocity on the sides. This is because the friction that we will have with the walls will be bigger than the friction that we will have with the same fluid. Then, if we open this channel from one side, the fluid tries to go with the wall. But in this case, one part of the fluid has a biggest velocity, so goes faster than another one. So the direction will change, and because the velocities are different, this fluid starts to rotate, and here we will have a vortex. And if we have a sunlight upside, we will see these shadows on the bottom of the pool. And this is so interesting because we can have different applications, for example in an aircraft, when we have vertical winds and we need to have a stabilization of the aircraft. We can use these theorems and these laws for make an aircraft more stable. This is all for today. Thank you for watching. If you like this content, subscribe, and I will see you the next Saturday at 12 with the next video. Bye bye!